Good afternoon. From the apple that was offered to Eve in the Garden of Eden to the apple that fell on Newton's head and inspired him to understand the nature of gravity, knowledge and its pursuit in science as a reward has always come with a risk. No one understands this better than myself. As a geneticist and founder of Genesis at the forefront of gene therapy, I know what dangers exist in our field. But the trick here is not to throw away the apple for the sake of the worm. Here in these tiny molecules, these building blocks of life, scientists like myself are learning more about what makes us human. At Genesis, our current focus is the genetic origins of cognition and consciousness. My team has been pioneering research in this field, using chimpanzees as test subjects. We do this work because what is remarkable about chimps and humans is that our DNA sequence is 99% similar. As my colleague Franz de Waal of Emory University says, Darwin wasn't just provocative in saying that we descend from the apes. He didn't go far enough. We are apes in every way, from our long arms and tailless bodies to our habits and temperament. So what is it that makes us different than our simian cousins? It is that remarkable 1% difference in our molecular codes that have led to our very different stations in the web of life. Because of that 1% difference, humans now dominate every ecosystem on Earth, while chimpanzees and other great apes risk extinction within the next few decades, largely because of us. 1%. Such a small but crucial number. It is in that 1% that we find the keys to the genetic codes of what makes us human. This critical 1% impacts the frontal cortex, that area of the brain that governs the center for expression of language, planning, strategy formation. In other words, it is where we develop personality. Tragically, the frontal cortex is also the area of the brain targeted by the most vicious of the neurodegenerative diseases like Parkinson's, like Huntington's, like Alzheimer's. When we see our fellow humans stricken with diseases like this, we have to ask why. Which brings me back to the risks of gene therapy and the rewards of medical technology that can make a difference. Some might be critical of our work and say that we are playing God. But I would argue that God is our highest instinct to know ourselves, and that the study of our basic genetic code and its wonders and its failings is the fundamental shift of us participating in our own evolution. Why must we suffer at these natural limitations in our genetic code when we now have tools to understand and rewrite our genetic destinies? This is not arrogance. This is progress. If our shared ancestor with the chimpanzee had not made the decision to walk erect and create complex tools, you and I would not be here today. Similarly, where will our descendants be if we do not fight for the reward that comes with this risk? Even after 20 years, gene therapy is still a growing field, but the implications of our work are profound. Our work, led by the head of research, Dr. Will Rodman, if successful, would allow for a cure for Alzheimer's. Let me say that again. A cure for Alzheimer's. On behalf of the loved ones that we have lost to this disease, how can we not afford to take this risk? But this is still just the beginning. My role here as a scientist is not always to have the right answers, but to ask the right questions. And that is what I ask of you.